Let's look at another situation. In this case, we're going to vary volume and temperature and see what happens to the other one. We're going to assume that pressure remains constant. Pressure remaining constant, it can only happen if the volume can change as it's heated or cooled. And that's pretty true with a balloon, as long as it's not filled up really tight. So anyway, if we have our balloon and no gas is escaping, no gas is coming in, of course, and we warm it, what's going to happen to the volume of the balloon? Well, the balloon is going to expand. So in other words, the volume will increase. And if we wanted to calculate how much it increases, we could use this equation. In other words, I could plug in my T2 and I have my V1 and T1 from before, and I would have a T2 here. I could solve for the second volume after it got warmed up. Again, on this one, pressure is constant and it's a closed container. Let's look at how this works. Here's our gas, and this container can expand, and I do have it set so that the pressure should remain constant. If it gets a little off, it will adjust, the volume will adjust to keep it constant. So let's see what happens when I warm it. When I warm it, it does expand. And what's happening is that the particles are moving faster and they're colliding against the container wall harder. And because the container wall gives, it gets pushed back to make it a bigger volume. Let's see what happens when I cool it. And so just the opposite, like we would think, as we cool it, the particles are not moving as fast, and so they're not pushing as hard against that container wall. If this were a balloon, you could imagine that the balloon would just kind of squish inward until the pressure is remaining the same. So we already knew this, that if you heat it, it will expand. And if you cool it, it will contract. Think about what that does to the density of the gas. If it's expanded, its volume is getting bigger, but its mass would stay the same because it has the same particles. So it gets less dense as you heat it and more dense as you cool it.